Hello students, today we are going to see the examples from the Science and Technology Part 1, first topic, gravitation. Let us see what is essential before starting the examples. So, before starting these examples, we should know few basic things, means which is called what, that is first u. What is this u? It is called as initial velocity. Next is v, which is final velocity. Next, a, we call this as an acceleration, right? This a, sometimes whenever we need an acceleration due to gravity, we use g also. So a is equal to g also. Even g, which is called as universal gravitation or gravitational constant, which value is 6.67 into 10 raised to minus 11 Newton meter square per kg square. So these all things we are needed before solving those examples. We have force, right? Force formula we know before in 9th standard which have studied, m into a, product of mass into acceleration. But in gravitation we have studied F is equal to g capital M small m upon r square. So most probably in this topic we are going to use F is equal to g m upon r square. We can denote this in small letter also if we have two other objects m1 into m2, right? As you all know, there are three equations of motions. Let us see one by one. V is equal to u plus 80. Second one, S is equal to ut plus half 80 square. Third one, v square is equal to u square plus 2as. Here final velocity, initial velocity, acceleration, time. Here displacement, s, small s. Sometimes wherever we need, we take s as an h also, the distance. Here again final velocity, initial velocity, 2 times acceleration into displacement. This s is smaller, I write it little bit smaller, small s. Here also it is small. Even v is also small, u is also small. All the letters here are small, right? Now, right, during free fall, suppose I am holding this marker and I am leaving this. This is a free fall which we have studied in the topic gravitation. So first, this marker is at rest. So initial velocity will be 0, which means here u will be 0, right? So whenever there is a free fall, so what happens to this? Now this marker falls down under the gravitational force. So in place of a, what we are going to do? We are going to write it as g. So the same equation will get converted. V is equal to, as u is 0 and a is g, we get gt. Again u is 0, so 0 multiplied by any number is 0. So what we get? S is equal to half. In place of a, we get gt square. Here v square equal to, again u is 0, so we get 2as. So we are going to use, whenever there is a free fall of an object, whenever the example comes of free fall of an object, we are going to use this. But while solving, even if you take this equation, it doesn't make any mistake. So here again, in place of A, you have to take G. So we can take this equation also, right, directly, or we can take directly this equation also. Okay, understood? One example. Okay, students. Now let us see one example from the exercise. Question number 2D, that is the fourth one. What is it? A stone thrown vertically upward with initial velocity u reaches a height h before coming down. Show that the time taken to go up is same as the time taken to come down. Means suppose this is a stone and it is thrown vertically upwards. So its initial velocity, you can see, can you see? Can you see here? Can you see this? Now it is a stone, suppose. Now I am giving initial velocity u. It went to a particular height, upward, vertically upward. Its initial velocity was u and it reached a height h. So from here, from where I have thrown it vertically, from that point till that point, let us say, suppose this is a stone and I have thrown it vertically upward. It reached over here, right? Let us take it as height h, right? So from here it has been thrown. So if you take this as A and this as B and height as h, right? So what is the time taken by it to go here, and again from the same it comes down till here from where I have thrown, that is from again B to A. How much time it takes? Show that the time taken to go up is same as the time taken to come down. They have already said that it takes the same time. Now whatever the time it has taken from A to B, let us take one example as 2 seconds. So it will take same time, that is again 2 seconds to reach again at the same point. Understood the question? Now let us see how to solve this solution. Before this, I have told you we need different equations of motion. So let us take the first one. V is equal to u plus at. Let us take it as equation 1. Now this, what I am going to do, V, I will keep it as it is. I will bring A over here, at over here. It becomes minus equal to u. That is u is equal to V minus at. We can make this as equation 1 instead of this. Right? Now let us take another second equation. S is equal to ut plus half at square. This is equation 2. Now let us substitute the value of u in this equation. That is, what is u? V minus at, and this t of this equation plus half at square. Now let us multiply this to this bracket. V into t, Vt minus a t square, t into t square, half a t square. Now here we have half. So what we are going to do? We are going to take the denominator or LCM. What we get here? Right? Half. So we have to multiply by 2 and divide by 2 into Vt minus again multiply by 2 divided by 2. What do we get? At square plus, there is no need of doing anything over here because already it is here. So what do we get over here now? 2 we get as a common. All the LCM is same. So here 2 Vt is minus 280 square plus 80 square upon 2. So what we get? 2 Vt. Now minus 280 square plus 80 square. We get minus only 1 here, nothing is 1. So we get 180 square, that is only 80 square upon 2. So let us take again 2 Vt. Let us separate this denominator upon 2 minus 80 square upon 2. So here 2 get cancelled, and what we get here now? S is equal to Pt minus half 80 square. So why we are doing all these things? So we are doing this to show that the time taken to go up is same to come down. Now as we have derived this equation, S is equal to Vt minus half 80 square, which we will give as equation 3. Now you know, as the stone is moving from A to B, that is from here till upward. As the stone is moving upward, that is from A to B, from A to B, right? Now that is displacement is from A to B, and what is that? How much is the displacement? H. And the time taken from going up, let us take it as T1, and A, as I told you, it will be G. A is equal to G, but here we are taking minus G. Why? Can you tell me? Because our acceleration is moving upward, but gravitational force is acting downward. So here G will be negative. It is retardation. And initial velocity, whatever they have given, initial velocity as u, and final velocity when it reaches at point B, it will be 0. It comes to rest, so its final velocity will be 0. Now from equation 3, that is S is equal to Vt minus half 80 square. S, we know what it is, H. Let us substitute those values. H, V is what? 0 multiply by T is what? T1, half minus as it is, half as it is. A is what? Minus G into minus G into T again, T1 square. So what we get here? Any number multiplied by 0 is 0. Minus minus plus. So half G T1 square. Therefore H is equal to half G T1 square. Let us label it as equation A. Right? Okay. Now let us see. Now this equation we got when a stone is moving from A to B. Now we have to find what we get from when the stone moves from B to A. Now here the initial velocity when the stone has reached the highest is 0. That is, as the stone is moving downwards from B to A, let us take time t as t2, and initial velocity when it is reached the highest point, it is 0. So from there it starts. So u as initial velocity as 0, and displacement will be the same, that is h, and a is equal to g. Why? Because it is acting in the direction of the gravitational force. So from equation 2, let us see, from equation 2, which we had seen before, S is equal to ut plus half 80 square. So what we get here? S as h, u as 0 multiply by t2 plus half a as g, t as t2 square. Any number multiplied by 0 is 0. So g t2 square. So what we get? Therefore h is equal to half g t2 square. let us take this equation as b, right? From equation a and b, what do we get? H is half g t1 square and h is half g t2 square, means both are equal. So what we get here? T1, or we can substitute this in this way, half g t1 square is equal to half g t2 square. Half g get cancelled, and we get t1 square equal to t2 square, taking square root of both sides. What do we get? T1 is equal to T2. As both kind are positive, so we'll get the square root as T1 equal to T2. So friends, in this way we can show that whenever a stone is thrown vertically upward with initial velocity u, which reaches at the height h, before coming down, then the time taken by the stone to go up is same as that of the time taken for that stone to come down to that particular height only. So understood, students? So if you have understood, wherever in the beginning I have started with the example, so we have not written that. You can take that particular initial given, this equation 1 2 3, take the screenshot and of that particular part, and you can continue or you can solve this example.